This is our view on the electron dot structures. First, you can copy everything printed on this digital blackboard. So the electron dot structure shows how the electrons are arranged around individual atoms in a molecule. A molecule is a combination of two or more atoms. An example would be FCl. FCl is composed of two atoms, fluorine atoms and a chlorine atom. So again, atoms are bonded to each other because they either share or transfer valence electrons. And why do atoms need to share or transfer valence electrons? Well, in this case, they want to obtain the best electron configuration, the most stable electron configuration, and according to the octet rule, atoms are stable when they have 8 valence electrons, and some are duet. So some follows the duet rule. It states that some atoms are stable when they have 2 valence electrons. This is true for smaller atoms like hydrogen, helium, and other elements. So the electron dot structure is composed of three parts. We have the symbol of the elements. Next are the dots. The dots represents the valence electrons. Again, only the valence electrons are shown in the electron dot structure, not all the electrons. So the valence electrons are the electrons found on the outermost energy level. So they are the farthest from the nucleus. We can get this one from knowing the electron configuration of an atom. So fluorine have 7 valence electron, and so we have here 1, 2, 3, 4, 5, 6, 7, and chlorine also have 7. 1, 2, 3, 4, 5, 6, 7 valence electron. Again, both of them wants to have the octet, so they share one more valence electron to each other. So both of them now have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7 plus 1 from the Cl atom. The same for Cl, it has 7 valence electron, sharing 1 from the fluorine atom. So both of them are stable when they share one pair of, when they share one electrons to each other. So let's try HCl. HCl is a molecule. Is composed of hydrogen atom and a chlorine. Now, hydrogen atom and a chlorine atom. So first we'll try to write their symbol. The next we'll try to know their valence electron. Hydrogen have 7 valence electron. No, sorry, it's 1 valence electrons. Chlorine have 7 valence electron. And hydrogen wants to follow the duet rule. It needs 2 valence electrons. And Cl have 7 valence electron, but it wants 8 valence electrons following the octet rule. So hydrogen needs more 1 valence electron, and chlorine needs also 1 more valence electron. So in this case, they form single bonds. So we'll now check the number of valence electrons. Hydrogen have 1 valence, which is correct here, and Cl must have 7 valence electron on this diagram. 1, 2, 3, 4, 5, 6, 7. So both of them are stable now. So this is the electron dot structure for HCl. Let us try CO2. CO2 is composed of 3 atoms. So it can be visualized as this one or this one. So which model is correct? Again, it says 3 atoms, so it's important to know which atom is the central atom. For that one, we need to follow this one. So the first thing is to pick the central atom. The central atom will be the atom with the lowest electron negativity. So we'll check their electron negativity first. Carbon have 2.5 and oxygen have an electronegativity of 3.5. So carbon has the lowest electronegativity, and therefore we'll put carbon in the center. We have oxygen, oxygen. Next is to know their valence electrons. Oxygen 6, carbon 4, and oxygen have 6 valence electrons. The next thing is to satisfy the terminal atoms. So determine how many electrons is needed by individual terminal atoms. So we'll first make the terminal atoms happy. In this case, carbon is the central atom. Oxygens are the terminal atoms. So we'll first make them happy. So all of these atoms wants to have an octet, so they all of them wants to have 8 valence electron. For now, oxygen have 6, and therefore it needs 2 more valence electron, and oxygen also needs 2 more valence electrons. So on this case, they form double bond. So it means that they are reaching out, that they are sharing 2 valence electrons from carbon. The same thing for oxygen, it will try to get or to share 2 more valence electrons. Next is to make sure that all the valence electrons are placed in your electron dot structure. So we have here oxygen must have 6 valence electrons. We have 1, 2, then 3, 4, 5, 6. Then oxygen also must have 6 valence electrons. 1, 2, 3, 4, 5, 6. And carbon must have 4. 1, 2, 3, 4 valence electrons. If we check this one, all of them are now stable because we have 1, 2, 3, 4, 5, 6 plus 2 from carbon. That will be 8 valence electrons. Carbon also have 4 valence electrons, but sharing 2 from oxygen, then 2 from oxygen.